Ever wanted to build your own smart home devices? Skip the expensive, cloud-connected stuff and make something yourself? Well, today we're doing exactly that. We're going to build a smart, totally private temperature and humidity sensor from scratch, and it'll only cost you a few bucks. All right, let's get into it. So here's the game plan. We'll break it down into 5 easy steps. First, we'll meet the tiny brain of our project. Then I'll run you through the shopping list. After that, we get hands-on connecting the hardware. We'll program it using an awesome tool called ESPHome. And finally, the magic moment, seeing that live data pop right up in Home Assistant. First up, let's talk about the heart of this whole operation. Meet the hero of our story, the ESP32C6. I mean, look at this thing. It's about the size of a postage stamp, but don't let that fool you. This little guy is an absolute powerhouse. And the best part? It is dirt cheap. It's kind of crazy how much they crammed into this thing. You get Wi-Fi and Bluetooth right out of the box. It even supports the newer smart home standards like Zigbee and Thread. It barely sips any power, which is perfect for projects you want to run on a battery. And yeah, you can find some of these for literally $1. It's just an amazing bit of technology. So here's our mission for today. We're going to take this tiny chip and turn it into a smart temperature and humidity sensor. And it's going to feed all its data directly into Home Assistant, the go-to open source platform for your smart home. Everything stays local, everything stays private. No cloud, no subscriptions. Okay, you sold? Ready to build one? Awesome. Let's run through the shopping list. It's super short. Here is everything you'll need. We've got the Xiao ESP32C6, that's our brain, then the SHT3 sensor, that's what's actually measuring the temperature and humidity, and then just some basic stuff like a breadboard and some jumper wires for connecting everything without any soldering. Seriously, for the main parts, you're looking at around 12 euros or dollars. Super affordable. Now, listen up, because this is a fantastic piece of advice from the source material. Buy more than one of the microcontrollers. Trust me on this. See, these little boards have pins for different voltages, like 5 volts and 3.3 volts. If you accidentally connect the wrong wire to the wrong pin, poof, you can fry the chip. It happens. Having a spare just means you can laugh it off and keep going instead of waiting 2 weeks for another one to arrive in the mail. All right, we've got our components. Now for the fun part, actually putting it all together. And I promise this is way easier than it looks. So how do these little electronic parts actually talk to each other? Well, they use a protocol called I2C. And I know that sounds super technical, but it's not. All it really means is that we only need 2 little wires to handle all the communication. One for the data, which is called SDA, and one to keep the timing straight, which is called SCL. The wiring itself, it's ridiculously simple. It really just comes down to 4 little wires. We connect power to power and ground to ground. Then we connect those 2 special I2C lines, clock to clock and data to data. That's it. The physical part is, well, it's done. So our hardware is all hooked up, but right now it's just a bunch of parts sitting there. We need to give it some instructions. Let's bring this thing to life. Now you might be thinking, okay, here it comes, the hard part, the coding, right? But what if I told you we don't really have to write any, code at all? The secret weapon here is ESPHome. It's this amazing framework made exactly for projects like this. Instead of writing hundreds of lines of C++ or Python, you just describe what you built. You write it down in a super simple text file. ESPHome reads that file and does all the hard work for you, building the actual program behind the scenes. It is, without a doubt, the fastest way to get a smart device up and running. And this is it. Seriously, this is the entire program. Just look at how simple and readable that is. We're just telling it which GPIO pins, those are the physical connection points on the board, we used for our data and clock wires. Then we tell it we have a sensor, give our readings a friendly name like living room temperature, and tell it how often to check for an update. That's everything the chip needs to know. It's more like writing a recipe than writing code. Okay, we've got our hardware assembled and our program written. Let's do the final step and get that sweet, sweet data flowing into Home Assistant. Getting this program onto the chip is called flashing, and ESPHome makes this a total breeze. You literally just plug the ESP32 into the machine running Home Assistant with a USB cable. Then, inside ESPHome, you find your new device, click Install, pick the right USB port from the list, and click Install again. It takes care of the whole upload for you. And here is where the magic happens. The moment that thing is flashed and it hops on your Wi-Fi, Home Assistant just sees it. You'll get a little notification that says, "Hey, found a new device." It's automatically discovered, ready for you to add to your dashboard with a single click. No messing around with IP addresses or anything. So let's just step back for a second and look at what you've actually built. You've got a sensor streaming real-time data. It's 100% private and local. No data is being sent to some company's server. It's cheaper than almost any commercial alternative. But more importantly, you now have the skills and the basic foundation to build all sorts of other DIY smart devices. This is a brand new, powerful tool in your home automation toolkit. And that really brings us to the most exciting question, doesn't it? Now that you have this power, the power to get almost any kind of data you want into your smart home, whether it's temperature or motion or light, what are you going to automate next?